Hi everybody, we're going to talk about reacting mass calculations today. I've sent you this PowerPoint through email and through Teams. So you can start by watching free science lesson videos, and this one will explain how to calculate reacting masses with very simple balanced equations. Then we'll use more complex balanced equations on this video. Alright, then there is a reacting mass calculation introduction sheet for you to print off, or you can try and edit it online, but probably printing off and actually using a pen is going to be easier. And you will also need your periodic table. So the first four of the questions here on the introduction page are covered in this PowerPoint. Okay. So your instructions are, when you're looking at your balanced equation, you write a tick or a question mark. The tick is on the chemical that you know the mass of. The question mark is on the chemical that you don't know the mass of, that you've got to find out. Step 2 is to find the moles of the one that you know the mass of, because once you've got the mass, you can use your periodic table to find the MR. And then with those two numbers, you can work out your moles. Then you have to do a ratio. If you've got a small number of moles, you've got to see what the ratio of molar reaction would be, and I'll talk through that. And then you find the moles of the one with the question mark over using a balanced equation. And then now you know the moles of the one that you didn't know the moles to start with. You can then calculate and find mass. That should say mass equals moles times MR. Okay? Right, so our first one. What mass of oxygen reacts with 12 grams of magnesium? The balanced equation is 2 moles of magnesium would react with 1 mole of oxygen to form 2 moles of magnesium oxide. The thing that we know the mass of is our magnesium, so we put a tick over that. The thing that we don't know the mass of is the oxygen. We need to find that out. Okay? So our moles of magnesium, we need to work out first, is going to be our mass over MR. Now we know the mass is 12, and we use our periodic table here to find our mass of magnesium, which is 24, our molar mass. Okay, so our mass in grams is 12, our molar mass is 24. 12 divided by 24 is 0.5 moles. So now we've got a ratio. So we know that really 2 moles of magnesium would react with 1 mole of oxygen, but we've only got 0.5 moles. So 0.5 moles of magnesium would react with half of that, which would be 0.25 moles. So our moles of oxygen is 0.25. So you're just doing a very simple ratio. If 2 moles of magnesium reacted with 1 mole of oxygen, therefore 0.5 moles of magnesium would react with 0.25 moles of oxygen. So now we use the calculation to work out the mass of oxygen. We know the moles, we know the MR from our periodic table here. Oxygen, relative atomic mass is 16. Oxygen is a diatomic molecule. It goes around with another of itself, so it has a little 2 down here, so that's its formula, chemical formula O2. So when you calculate its MR, it's going to be 16 times 2, which gives us that number 32. We've worked out the moles above, 0.25, so our mass comes in at 8 grams. Okay, the next demonstration is question 2 on our reacting mass calculation sheet introduction. What mass of calcium hydroxide is made from 14 kilograms of calcium oxide? So there's our balanced equation. Calcium oxide plus water gives us calcium hydroxide. We know the mass of calcium oxide. We want to find out how much calcium hydroxide is made. So, because we know that, we know the mass, and we can work out the moles of calcium oxide. The MR, using our periodic table, we're going to find our formula mass. Calcium here is 40, plus oxygen here is 16, so that's going to be 56. We've converted our kilograms into grams. So we've got 14,000 grams divided by 56, which will give us 250 moles. So a lot of moles, but it was a very big weight, a very big mass of calcium oxide. So the next step now is to look at the ratio. 1 mole reacts to form 1 mole. So 250 moles is going to react to form 250 moles. So the moles of calcium hydroxide we're going to make is 250. Using our formula mass, we're going to work out what the formula mass of calcium hydroxide is and therefore what the molar mass is. So again, 1 calcium, 40, plus 2 oxygens, because oxygen here, let me just lift that across slightly. Oxygen here is in a bracket, so it's 2 oxygens. So it's 40 plus 32 plus my 2 hydrogens. And hydrogen, of course, is a mass of 1, which will give me a formula mass of 74. I'm going to times that by my 250 moles, and my answer is 18,500 grams. Okay, you can either pause this video now and keep working through by yourself, or I will keep talking through these last few ones and then you can have a go at page 2, the reactant mass calculations 2 by yourself. Okay. So what mass of aluminium is needed to react with 640 grams of iron oxide? So we know iron oxide, 640 grams. Let's put a tick above that. We want to know aluminium. We're going to put a question mark above that. So we know the mass. And we know the MR from our periodic table. We can work out our moles. The MR is going to be 2 ions. Iron in my periodic table is here. 2 ions plus 3 oxygens, which will give us an MR of 160. So 640 grams divided by 160 is 4 moles. So we start off with 4 moles of iron oxide. We're going to react it with 2 moles of aluminium. So if we have 1 mole of iron oxide, the ratio is 1 mole of iron oxide will react with 2 moles of aluminium, but we've got 4. So 4 moles of iron oxide is going to react with 8 moles of aluminium. So we now have to calculate the mass of aluminium. We now know how many moles we've got, and we can work out the MR from our periodic table. Aluminium's there, 27. 27 times 8, 216 grams. The mass of aluminium is 216. Okay, last one. What mass of titanium chloride reacts with 460 grams of sodium? So we know the mass of titanium chloride. We want to find out how much sodium. We know the mass of sodium. We want to find out the mass of titanium chloride. So our tick goes over sodium and our question mark goes over titanium chloride. So let's work out our number of moles we actually have of sodium chloride. It's going to be the mass. Let's work out the moles we actually have of sodium. It's going to be the mass over the molar mass, which is going to be 460 grams over 23. So that's 20 moles. The ratio is 1 mole of that reacts with 4 of that. So if I've got 20 of that, how many moles of titanium am I going to have? I'm going to divide it by 4. I'm going to have 5. So in reality, I've got 5 moles of that reacting with 20 of that. So let's work out our mass of 5 moles of titanium chloride. So from my periodic table, have a look for titanium here. No, mine's gone missing. Here, titanium. You've got 1 titanium and 4 chlorines, which gives you a molar mass of 190. You've got 5 moles, so times it by 5 to work out our actual mass of 950 grams. Email me now if you've got any problems, and then otherwise have a go through reacting mass calculations 2, which is another 5 questions. Okay.